name is Derek from Tomcat Gas Training, and today's video is all about commissioning one of these. So what we're going to be doing is we're going to be going through the commission procedure outlined by the manufacturer Ariston for this eCombi 1, and we're going to be looking at filling in the benchmark. Okay, so first of all, let's find out what the benchmark book is all about and what the benchmark scheme expects us to do. Let's get on with it.
After a 12-month review by the Heating and Hot Waters Industry Council, the HHIC, significant changes have now been made to the Benchmark Gas Appliance Commission scheme to bring it in line with the government Boiler Plus legislation of 2018. The Heating and Hot Waters Industry Council, in partnership with major boiler manufacturers, installers and representatives across the supply chain, have revisited the benchmark scheme and updated the commissioning checklist to take it into 2020 and beyond. Since April 2018, all boilers installed in the UK have required to achieve at least 92% efficiency, that's the ERP, Energy Rated Product Efficiency, and must have a working timer and temperature control. The legislation was introduced in an effort to improve the energy efficiency of all UK homes. Combi boilers are also required to have at least one of 4 energy efficient features. So load compensation, which could be in a room stat. We've got weather compensation, which would be installed outside, or could be part of a smart thermostat control, which will be connected to the internet and the weather stations through the internet. Or we can have a flue gas heat recovery system, which could be installed integral with the boiler or can be separately outside the boiler, depending on the manufacturer's spec. Since its launch in 1999, the benchmark scheme has been promoting quality for the installation, commissioning and servicing of domestic heating and hot water systems. A lot has changed since then, and it is important that the scheme reflects modern day-to-day practices, standards and legislation. The benchmark scheme is an industry initiative introduced and administered by the Heating and Hot Waters Council, which outlines the responsibility of the manufacturers' installers regarding the safety and efficiency of heating and hot water products, including ensuring compliance with the building regulations, document L. It is included in the installation and commissioning procedure booklet provided by the manufacturer as a minimum standard for the commissioning. After the review, the benchmark scheme has now also been updated to comply with Boiler Plus standards. Completing the benchmark checklist is already means of meeting the commissioning requirements within Part L of the building regulations, and embracing benchmark is the most straightforward way to help make sure you comply, as the documentation is already supplied with the appliance. Standard recommissioning checks should include flushing the system, checking for water leaks, testing for gas tightness, ensuring the correct installation of the positioning of the pressure relief valve, the flue and the condensate pipe, while completing the gas safe installation and use regulations 26.9 checks. They should also ensure that the flame supervision device is working correctly and checked. When the installer commissions the boiler, you should complete the benchmark checklist. If you fail to do this, the manufacturer's warranty will be void. The boiler needs to be registered with the relevant manufacturers from the date of the installation, and the boiler must be registered with Gas Safe for building control compliance. The benchmark covers gas heating and hot water systems, hot water storage cylinders, water treatment products, and solar thermal systems. Now let's have a look at the changes to this document. So you can see on the left here we've got the new one, and you can see the changes from the old one. So let's have a closer look at that and any of the other documents we need to complete. So the first benchmark sheet we're looking at now is the old one, and let's start at the controls. So you can see the section here for the controls. It's just asking Have we got a room thermostat, program timer, load weather compensation, program room thermostat, optimum controls. But if you look on the new one, you can see the difference. Okay, so Boiler Plus option choices for in England. So you got weather compensation, load compensation, smart thermostat, and you got flue gas heat recovery. This has all stayed the same from the old one. Okay, except it says pre-existing on the old one. It just either said fitted or not required. So back to the old one, you can see all the systems. Has a system been flushed in accordance with BS 7593? Okay, and then asks you how much you've put in and what inhibitor you put in and cleaner you put in. Also says, have you done a primary water system filter being installed? So on the new one, it says again, has it been installed to BS 7593? But this time it wants to know, was the filter pre-existing? Okay, have you fitted it or is it not required? So that's what we're looking at for the water quality.
Let's just have a quick look at this new British Standards BS 7593 2019. So the revised British Standards BS 7593 2019 has been introduced for the preparation, commissioning and maintenance of domestic heating and cooling water systems when it supersedes BS 7593 2006. The standards now include the following key changes for those specifying installation and maintenance of domestic heating and cooling systems. The fitting of a permanent inline filter is required in addition to a chemical clean and fresh water flush before inhibitor is added. An inline filter should be fitted to all systems.
All recommended cleaning methodologies can be improved with external magnetic capture equipment and mechanical vibration of radiators.
The water test is required to test the levels of inhibitor and the cleanliness of the system every year. Inhibitor should be redosed every 5 years or a full system water test must be undertaken. BS 7593 2019 is now applicable to both closed loop and heating cooling circuits.
So if we have a look at the central heating mode, it says gas rate, burner operating pressure, if applicable, and it's giving you the information there. On the new one, it says gas rate for combination boilers, complete domestic hot water mode gas rate. And then it says central heating output left in factory settings. So we've got a difference there already. If no, what was the maximum central heating output selected? What's the dynamic gas inlet pressure? Central heating flow temperature, so they've stayed the same. And has the system been correctly balanced? So that's the big changing for the central heating from the old one. Let's have a look at the hot water. So on the old benchmark, it said domestic hot water mode, measure and record the gas rate, burner pressure as per the central heating. But it says it wants to know the cold water, have we checked the hot taps and what temperature is it, and what's our flow rate in litres a minute. On the new one, it says domestic hot water mode, measure and record. Again, it wants the gas rate. Again, it wants a dynamic inlet maximum pressure, but the gas rate is asking for meters cubed an hour or cubic feet. Doesn't actually want to know kilowatts for some reason. I always write the kilowatts in here, but there you go. Cold water, inlet temperature we still want, and the hot water being checked at all the outlets, yes, and what's the temperature. Next one, condense. So has the condense been installed to BS 5546 or BS 6798? But this time it's asking point of termination and the method of dispersal, whether we're internal, external, whether we're in gravity or whether we're pumped. If we look at the old one for the condensate, it just says condensing boilers only, as a condensing drain been installed according to the manufacturer's instructions, and BS 5546 or BS 6798. That's all it asks for. And then on the old one, the last bit, it's asking us for flue gas analyzer readings on maximum and minimum, And that's pretty much the same as it is on the new one. With these few instructions at the bottom, it says, where possible, has the flue integrity checks been undertaken according to manufacturer's instructions? That wasn't on the old one. The operation of the boiler and safety controls have been demonstrated and understood by the customer. That was on the old one, and the manufacturer's literature, including the benchmark checklist, again was on the old one. So we've got to do now the flue integrity, but it says where possible. Okay, on all new boilers now they will have an integrity point. On the old ones, some of them did and some of them didn't. So that's the changes of the paperwork.
Now the first thing is always after the completion of the installation of a gas appliance, we need to carry out a tightness test first. So we did a tightness test before we did the installation. Now we need to do a tightness test after to prove we've left no leaks. So we've got no leaks on the new pipework. So the first thing I'm going to do is I've isolated the gas supply. I'm now just going to remove the test nipple with my amazing little Wearer socket. So it's a 10mm socket, and I always try and use a socket rather than a flat blade screwdriver because you can damage the test nipple. But just remember guys, don't tighten it too tight. But I'd just like to thank Tomcat's German engineer Connor, thanks Connor mate, for giving me this as a present. Cheers mate. Now first thing I need to do is I need to pair my new SP620 or 620 with my app. So I'm going to turn it on, tap this, oh look, it's come up straight away. Can now tap that. We're now ready. I want to go on to the bottom here where it's tightness testing. Let's zero the manometer, and this is now ready for connecting to the meter by just putting it on the plus. I can now carry out my tightness test. So let's get on with that first. Now, as always, on the tightness test, the first thing I'm going to do is a let by test to see whether a ECV is letting by. And you can do this between 7 and 10. And you can see I've done it at 9.37 millibars. So you have between 7 and 10 millibars for 1 minute. So I'm just going to wait the 1 minute now. After a successful, you can see it's gone up by 0.04 millibars. So that's passed because we have 0.025 millibars. Next I'm going to do is temperature stabilization. And you can see I'm doing this at 20.15, so I have between 20 and 21 millibars to do this. And again, it's a 1 minute test. So we're just seeing whether or not it rises or falls, and it can do whatever it wants. It can rise or fall. So you can see now at the end of this stabilization period, it's just gone to 0.04. So again, we can now do a tightness test. So the tightness test, I'm doing it at 20.21. And it's a 2 minute test. And at the end of this 2 minute test, it will tell me whether it's successful or not, and it's passed. Now, that's a successful tightness test completed. What it says for me to do now is I can create report. So let's create the report, print it off. We've got a copy to prove it's passed the tightness test. Now, after any successful tightness test, we now need to purge the system of air. So we need to get rid of this 5 to 15% gas in air so we don't get an explosion. So the only appliance we're looking at is this boiler. This is the only boiler, it's the only thing connected to this gas supply. We've no cooker to purge from, so we're going to have to purge from the boiler. So let's get purging.
Now if you want to know the full purge procedure and how to work out purge volumes, why don't you have a look at our video on purging on our channel. But you see, you need to open the windows, ventilate the room first. We need to take our first reading from the gas meter, so you can see it's 0.55, nearly, well, halfway between the 0 and the 1. So we need to go to the underneath the boiler now onto the gas connection and just undo the nut at the back of the gas supply, and we need to purge this minimum volume of 0.01 meters cubed or 10 decimeters cubed. So once we've done that, you can see the final reading now is 0.56, just over the 2, so that's the 0.01 meters cubed or the 10 decimeters cubed. So we're just going to re-tighten up the nut now we've passed that minimum volume. Make sure we tighten it up correctly. Couldn't have picked one of the worst boilers in the world for trying to tighten up underneath, but there you go. But after we've purged, because we're not going to be doing another tightness test, we need to make sure we spray the joint with leak detection fluid, LDF, and wait for at least 15-20 seconds before we wipe the excess off.
After a successful tightness test, we've purged. After a successful purge, we can now take our standing pressure. So I've still got my little SP620 still connected, so that's still here. I can now take my standing pressure, and at the moment my standing pressure is reading 26.5, so 26.50 millibars. So that's what my standing pressure is reading. So after I've done my standing pressure, I can now do my working pressure at the meter. So let's get on with that. Now, to get the working pressure for this boiler, I've still got it connected to the app. All I need to do is turn my tap on maximum. Okay. Now, some guys do their working pressure at the meter in maximum setting, but I've set my boiler on hot water to the maximum. Okay. I've opened the tap to give me a full flow rate, and I know this boiler will go on to full rate by doing this. Okay. And at the moment, my working pressure at the meter is 21.27. So that is our working pressure at the meter. And what we're looking for is a working pressure at the meter of 21 millibars plus or minus 2 millibars to show us that we've got enough gas coming in and the regulator's working correctly. So, working pressure at the meter, very important.
Now we've finished with the manometer at the actual gas meter, we can now put the test nipple back. You can now tighten it up, but remember, don't over tighten it guys, you can split the barrel of the test nipple. And then, because we've not able to test this, we need to now test it with leak detection fluid. No, I never turned the gas off all the time I was doing this, so I never allowed air back into the system. And after we've used our leak detection fluid, we can now wipe off the excess after 15-20 seconds to make sure we don't leave it to corrode the meter.
Great. Now, while we're at the tap, there's a few tests we can do now before we move on to the boiler itself. First of all, for the benchmark book, we need to know what our hot water temperature is, what our flow rate of our hot water is, and what our incoming water supply is, so we can work out the delta T. I'll explain the delta T on the board now. Basically, what delta T is the difference between the hot and the cold water. Our delta T, if cold water is 10 degrees C and our hot water is 50 degrees C, then our delta T would be 40 degrees C, because 50 minus 10 is 40 degrees centigrade. So basically, that is, in a nutshell, delta T, the difference between the two temperatures. You can also get delta T in central heating. That would be the radiator temperature, the water inside the radiator, to the air temperature in the room. That's another delta T. So delta T, in a nutshell, the difference between the temperatures of two things. We're back at the tap, so what we need to do now is, first of all, I need to get my cold water temperature. So I'm just going to turn the tap on to the cold I'm going to open the tap now onto its full rate. Doesn't really have to be on full rate, I just need to get it to run a little bit to be cold. I'm now using my thermometer. I can now take my cold water temperature and see what it comes out at. Now normally what I would do is, I'll try and see if you can see this. I get my weir cup and I place it in the bottom of the weir cup like that, and then take the temperature. So we need to leave it for a few minutes, a few seconds, to make sure it gets an accurate reading of our incoming cold supply. And it's really important that we do have the incoming supply cold temperature. So I'm getting a stable reading of 10.2 degrees centigrade. So that's my incoming cold water temperature, 10.2 degrees C. Now, according to the manufacturer of this boiler, Ariston, it says the 24 kilowatt boiler at 12.1 litres a minute at a delta T of 30 degrees, that's what we're looking for. For a 30 kilowatt at 30 degree delta T, or a 30 degree rise, we're looking at 14.5 litres a minute. Now if we go to 35 degree rise, that drops the 24 kilowatt down to 10.4 litres a minute, and the 30 down to 12.5 litres a minute. So it depends on how quick you open the tap. So to test that, what we're going to do is, on the 24 kilowatt, because this boiler's a 24 kilowatt, we're going to set our tap flow temperature to around about 10.4 litres a minute and see what hot water temperature we get coming out of this tap. And if we get round about this 35 degree rise, then happy days. If we get more than the 35 degree rise, even better. But if we get less than 35 degree rise, then we could have an issue. So let's try that now. So I've set the weir cup on to, the tap's flowing round about 10 litres. Just open it up a little bit more. So it's flowing around about 10 litres a minute now on the weir cup. I can now take the thermometer and I can place it in the bottom, and I now need to leave it to stabilise and give me a stable temperature reading. At the moment I have got 35, 36 and it's rising rapidly. So I'm now waiting for this to stabilise. Now combi boilers shouldn't let their water go above 60 degrees. And if the water does come out of this tap higher than 60 degrees, then the boiler should be knocking off. But it should modulate the boiler too, also to keep it between 50 and 55 degrees coming out the tap, or whatever the delta T is. So I've got now a temperature of coming up to 40 degrees. Remember, according to the building regulations, they reckon 38 degrees is good enough to have a bath. And they were supposed to be changing it at taps as well, which hasn't come out yet. We'll see what happens in April. But this is trying to keep steady now at 40 degrees, and now 40.3 degrees. So this boiler is giving me a hot water temperature at flow rate of 10.5 litres, around about 10.5 litres at 40.3 degrees C. So if we look at our delta T from this tap, our cold was 10.2, our hot was 40.3, so 40.3 minus 10.2 is 30.1. So that is our delta T for this tap and this boiler. Now, next test I'm going to do now is our inlet pressures. So again, I've got my little fancy weir socket set off Connor. So I'm just going to undo the inlet test point on this boiler, which is down at the bottom here. Okay, so I can hear the gas coming out. Again, I've got my SP620, and I'm just going to put it onto the test nipple. Okay, I can get this out of the way now. I'm just going to stick it on the side of the boiler. So that's out of the way because it's on my phone. So it's saying giving our standing pressure now of 25.4 and going up. Okay, so that's giving us our standing pressure at the boiler. Now, in the benchmark book, it says working pressure at the appliance in hot water and heating, not high and low. High and low setting is for flue gas analysing. So some guys do it on high and low, but the benchmark book's asking for it on hot water and heating, so what it's actually getting. Now, other boilers have a test point actually at the boiler, so where it comes in, at the gas isolation valve. And we should have no more than a 1 millibar difference between our working pressure at the meter and working pressure at the appliance. Now, Ariston don't give us that inlet test point, but what they do say is at the gas valve, in hot water and heating, it cannot go lower than 17.5 millibars. And that's from the manufacturers, and that's in the manufacturer's manual as well. Okay, so what we're going to do is, first of all, I'm going to put it on hot water, so I'm going to turn the tap on. You can hear I've got the hot tap running, and this boiler is now got an inlet pressure of 20.43. Okay, so round about there, so it's going between 4.3, 4.5, 4.6. So that is our working pressure at the gas valve, okay, on hot water with the tap running at maximum. Okay, let's try the central heating. Now you can hear the boiler's now in central heating mode, so it's not running at full pelt, it's running at maximum for the heating, for what it needs. So it is giving me an inlet working pressure of 22.29, 3.6, so it's slowly modulating around as it's going around. So that would be our inlet working pressure. Remember, it can go down to 17.5, what it's saying in the manufacturers. We're well in because we've got 22.41 now, 42, something like that. So that is the working pressure at the gas valve with the central heating on. And both hot water and central heating, I put them onto maximum on the temperature setting on the front of the boiler. Okay, so this is what its maximum would be.
And don't forget, once you've finished, remove your test hose, tighten back up your test nipple. Don't go too tight, you don't want to be snapping it. And then make sure you spray with LDF to see whether your test nipple is leaking or not. Obviously it'll bubble up. And then don't forget to wipe off the excess LDF with a clean cloth, trying to get all the excess off what's been left from by trainees.
Next test we're going to do is, we're back at the meter, so we're going to be gas rating. We're going to gas rate on hot water and central heating. Now let's look at the maths from the gas rate. So we'll start with the hot water. Next test, I've got the DC 710 with my K probes for doing the temperature. So this is our flow pipe, this is our return pipe. So that's taking the flow and return temperatures because I'm just waffling now. Now while I'm down here, I might as well check the flame rectification on this boiler, so the flame supervision device. Benchmark now says about balancing radiators. Carbon monoxide 0, carbon dioxide 0, no ratio, and oxygen level of 20.9. So that's our fluid integrity. Now, according to the standards, every boiler now has to have some kind of magnetic filter fitted to it. Now let's have a really quick look at controls, because this video is just going on. Right, now that is the end of part 1 of this how to commission a central heating boiler to the new benchmark. If you've liked this video, why don't you give us a thumbs up or leave a constructive comment down below. If you've not subscribed to our channel yet, then get subscribing, and don't forget to hit that notification bell because I release videos every Monday, Wednesday and Friday now. So all I've got left to say is thanks for listening, thanks for watching, and stay safe over these really hard times with the coronavirus. Cheers guys.